Alright, this is one of the most important lessons that we have because it's worth so many points. It's on almost every free response and it's worth 4 to 5 points. So, out of 108. So that's very important. So let's start up here. The order of a differential equation is determined by the highest derivative in the equation. So this is the third derivative. So this is a third order differential equation. Kind of similar to the degree of a polynomial. Is the highest exponent. So the order of the differential equation is the highest derivative. This is the only derivative in this equation, but alright. So this would be first order right here, because it has a first derivative. Okay. So just starting off, is the given function a solution to this differential equation? So that's fine. We need to know what the derivative is. So we need to take the derivative of this. So the derivative of e to the u is e to the u times du, which would be 2. Now we need to substitute in here. So that is 2e to the 2x minus y, which is right here, e to the 2x. And that is equal to e to the 2x. So 2 of these minus 1 of these is one of those. So yes, that is true. So yes, that's a solution to that equation. Alright. So let's try it again. So that's why that goes there. We also need the derivative. So we need to take the derivative of this. The derivative of that. That's a constant, so that's not really doing anything. So the derivative of e to the x is e to the x. And then here we just did this over here, so this is going to be e to the u times du. Now we need to substitute those things into that equation. So we're going to have c times e to the x plus e to the 2x minus c e to the x. That's the original, so that's e to the 2x, and all that needs to be equal to e to the 2x. So if you distribute this here, we say that this and this are going to cancel out basically, and then we're left with, hold on a second here, I didn't write this down properly, this is supposed to have a 2, I'm supposed to write this whole thing down here. And now we're back to kind of what we had over here. 2 of these minus 1 of these equals that. So that is true. So this is also yes. So you can't assume that one's going to be yes and one's going to be no necessarily either. Alright. So we've already done this these 3 main steps: separate, integrate, evaluate. So hopefully, I mean they do get a little more complicated with some of the examples that we're going to have here, but at least hopefully we have an idea. So the key that you should notice is when it says find the particular solution of a differential equation. So that's kind of when you know that you're doing separation of variables. So here we would multiply both sides by dx. And then we would divide, and so this is a little bit tricky. I'm going to do this one step at a time. So dy equals y plus 1 times dx. Okay, so what we need to do is we need the y on this side, but we're going to have to divide by all of this to get it over there. So dividing by y plus 1 on both sides will kind of give us this. So that's the separate step. Separate. Okay, now we're going to integrate both sides. So this one is the natural log of y plus 1, and this is just going to be x plus, and remember we would be getting a c on both sides, but then we would just be taking the opposite of this c over here and putting them together as a constant. So we don't really need to use substitution on that, because if that equals u, then du equals dy. So there's not, you just gotta, sometimes we do need to use the u substitution, so you want to be careful there, but Here, not so much. Now, here's where things can get a little bit tricky. So we're trying to solve for y, so we want to use inverse functions here. So we're going to raise e to these powers because we know that that's going to eliminate this. I think we did one like this at some point somewhere, but maybe not. So here we have two things. We're adding exponents, which means we had two things of the same base. So we had e to the x times e to the c1. Because when we multiply two things of the same base, we add the exponents. So we could rewrite that like this, and then realize that that's a constant itself. Okay, so that's going to leave us with c e to the x. And that is always positive, so I don't really need the absolute value there, because this is always going to be positive, so that's fine. Okay, and now we can move that around a little bit. Subtract 1 from both sides, so we'd have c e to the x minus 1. And then we could plug in the initial condition, so that's going to be 0, 1. So y is 1, and e is 0, and minus 1 there. So add 1 to both sides, that's going to be 2, and here that's just 1, so c equals 2. So our final answer is going to be 2 times e to the x minus 1. Okay, so let's try that again. So separate. If we separate, and we want to kind of switch this to dy dx. So multiply both sides by y times dy. On this side we're going to have x squared plus 7x plus 3 dx. Okay. So separate, integrate, evaluate. That separate step should be nice for everybody. Usually that separating step is multiplying or dividing. Don't get, sometimes students try to like subtract 1 over here. That's not going to work. You got to multiply both sides by dx. So you're going to get a product there, and that's going to join these together here. So most of the time it's multiplication or division, not addition or subtraction. Okay, so here it's going to be 1/2 y. Add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. And plus c1. Okay. So now we can multiply this whole thing times 2. That'll give us y squared 2/3 x cubed 7x squared plus 6x and plus a new c there. So here our initial condition is 0, -2. So we can plug these values in at a variety of different places. It kind of just depends where we feel comfortable. So to me this seems like a good place to plug it in, so I'm going to. Over here I waited till I was closer to the end. So if we plug in -2, we're going to have -2 squared, and this is 0 plus 0 plus 0 plus c. So c is equal to 4. So we have a plus 4 right here. Guess I'll write that out. I was going to try to maybe do another step, but okay. And so now at that point we're going to take the square root of both sides. Okay, and this is going to be the absolute value of y. So that's going to give us y equals plus or minus. Now, the question we should ask is it plus or is it minus? And hopefully some of you can figure that out. Think about it. Should we use the plus branch or the minus, the negative, the positive or the negative? Well, it has to do with the value of y. So if you look up there at the value of y is negative, which means this needs to be negative. So we are not going to use that. Okay. This is negative, so this would have to be the negative square root in order for us to get a negative 2. Alright. So let's try a few more. Four more, and then an AP question after that. Okay. So, here, hopefully you guys can do some of these yourself here. This is the point 210. So, we just got this y here. So basically we want to divide both sides by y. So that's going to be 1 over y dy, and this is going to be 2x over x squared plus 1 dx. Okay. So, a couple things here. So the next step is to integrate. So this side is pretty straightforward. That's going to be the natural log of y. This side's a little bit trickier. We're going to have a u substitution. So u is going to be that. du is going to be 2x dx. So that actually works out pretty nicely, because that's 2x dx right there. So that's going to be 1 over u, and when we integrate that, we're going to get the natural log of u, which is x squared plus 1. And let's see 1 right there. Now, we're going to raise both sides, e to those powers, so that we can cancel that out and see what we get over here. So again, don't forget this little move. Anytime you raise e and you have this plus c here, basically just memorize that that's going to put a c out in front. This before this cancels, I want to write it again. Really, I'm getting into the space over there, but hopefully from the other question on the other side you got that. And then that's going to be x squared plus 1. Alright. And our value's positive up there, and this is always positive, so this must be positive. So we have that, and now we can substitute our initial condition in. So we have 10 equals, and we have 2 squared plus 1, that's 5. So if we divide by 5, we get that c equals 2. So our answer is 2 times x squared plus 1. Okay. So over here we're pretty close. So here's one of those rare occasions where we're actually going to add or subtract, but that's because one side was equal to 0. So we're going to add that to the other side. 4y minus cosine y dy. Add this to the other side, and then multiply both sides by dx. So that's a little bit unusual. Then we will come in here and take the integral of both sides. So add 1 to the exponent, divide by the new exponent. The integral of cosine, well, That's going to be negative sine. The derivative of sine is cosine, but we want it to be negative, so we need this to be negative. Here, x cubed plus c. Alright, so we talked about there are kind of different opportunities you have to plug in the initial condition. So when you see a spot that looks good, I think this looks good before it starts getting messy. So if we plug 0 in there, that's going to be 0. The sine of 0 is 0, and 0 cubed is 0. So c actually turns out to be 0, and we're going to leave this one kind of implicit, or it's mixed up, because I don't know if we can get y by itself out of there. That's beyond my pay grade. Maybe we can, maybe we can't. So that's what it says right here. There may be some exercises in our textbook where you're just going to leave it like that. Now, on the AP test, you are pretty much always solving for y. I can't think of an example where they left it like that. I don't like to say never, but so usually you do have to solve for y. That's kind of the evaluate part. Okay, so let's take a look at these two. So this is worded slightly differently, but it's basically the same thing. So your clue here is that they're telling you that the slope is determined by this. So when you see that, you can kind of go, okay, that's going to be dy dx equals 2x over y squared. So now we're going to do the separate, so multiply, so that's going to be y squared dy and 2x dx. Okay, and then we're going to integrate, so that's going to be, and this should be pretty basic for you if you've been paying attention here. It's kind of the same. Add 1 to the exponent, divide by the new exponent. Over here, add 1 to the exponent, divide by the new exponent, plus c. Now, we can evaluate for c whenever we want, so I think I would rather just go ahead and find it now. So if we take that and plug it in here, we'll get 1/3 3 cubed equals 0 plus c. So 3 cubed divided by 3 is 3 squared, so c equals 9. And then we can go into 1/3 y cubed equals x squared plus 9. So the thing about this is, if you decide to plug that point in later, if you decide to solve for y first and then you plug that in, your c will be different than the c we got here, because it'll be the c that shows up actually right here. So we multiply this whole thing times 3, we would have 3x squared plus 27. So if we take the cube root of both sides, we'll get the cube root of 3x squared plus 27. And moving right along to the next one here, the solution to this. So this was very similar to something that was on the AP. It was on the AP test 2 years in a row, almost the same question. So the trick here, students got confused like what to do with this. So just treat this as kind of the constant of x and divide, so multiply by dx, and then you need to divide by this. So that's going to give you 1 over y minus 300 dy, and then this is where some people were throwing out. And you could multiply by 25 up there, but then you're just, I think you're just kind of convoluting things over there. Better to keep that numerator 1, I think. Alright, so that's the separate part. Like I said, there was some issues with that. Now we're going to integrate. And I think I mentioned this before, we had one, you could use u substitution on that, but you don't really need to, because that's what I'm. Now, the one that you have to be careful of is if these are reversed, If you have 300 minus y, then your dy, your du is negative dy, and so you do have to worry about that negative if the variable is negative, but it's not, so we don't have to worry about it yet. Over here, this is just going to be 1 over 25 times x plus c. Alright. So we've had a couple of these logarithm ones above there, so we're going to raise e to the power there. And again, memorize this situation. When you have that plus, the c is going to come in front here, basically. That's all. Just memorize what to do. I showed you on the front why that happens. Okay, and then on this, and now this all, there's no, c is a constant, and the exponent is the variable, so changing an exponent, whether it's positive or negative, doesn't change the sign. So that's always going to be positive, so we can kind of just focus on y minus 300 here. Okay, now we can go ahead and plug in 0, 1400 if we want to. So 1400 minus 300, probably could have done that in my head, but and then plug in 0 here, that's going to be e to the 0, which is 1. So c is going to be 1100. So that should pretty much do it. Y equals, I'm going to go ahead and add the 300 to the other side. So we'll have 300 plus, and then we found out that c was 1100, like so. Okay, so let's look at an AP question. One AP question here. It's the last question of these notes. And when you read these free response AP questions, you need to kind of break it down, take some notes on the question. So this question was on the 2011 test, or the 2012. I think this was the 2011. And the world average was 1.6 out of 9. And we had 2.7 out of 9. And this the next year was a very similar question, and the world went up to 2.9 and we went up to 4.3. So, you know, so some of it is just the preparation and being ready for certain kinds of questions. Okay, the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. Alright, the rate. So we're just kind of taking notes on the question as we go. Time equals 0. When the bird is first weighed, it is 20 grams. Okay, and kind of down here they kind of reiterate that for us. So if B of t is the weight of the bird in grams at time t days after it's first weighed, then, okay, so B of t is the weight, and then the differential equation is given by this. And then here's our function in terms of t. Okay, so this is the solution to this differential equation. Alright. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So here is the formula for the rate at which the bird is gaining weight. So if we plug 40 in there, we're going to have 1/5 of 100 minus 40, which is 1/5 of 60, which is 12 grams per day. Okay, and if we try the other one there, that's 1/5 of 100 minus 70, which is 1/5 of 30, which is 6 grams per day. So, gaining weight faster at 40 or 70? Well, here's the rate at 40, and here's the rate at 70. Well, that's more weight per day. So, we're going to say faster when 40 grams, and we're going to say dB dt 40 is greater than dB dt at 70. Now, maybe that kind of makes sense also, because if you think about when the bird is smaller, it's eating more and growing, probably growing faster. You grow more when you're a baby than you do when you're, well, depending on what you're eating. But anyway, never mind. So, that's the answer right there, pretty much. Probably 2 points, 1 point for the answer and 1 point for this, maybe. Alright. Now find the second derivative in terms of b. So we need to take the derivative of this. So that looks like this. So the derivative of this is negative. So if you distribute that, you would get a 20 minus 1/5 b. 20 minus 1/5 b. And if you take the derivative of that, you're going to get negative 1/5. And then the thing that most people missed on that was you need to put dB dt, the derivative with respect to b. Okay? So that's where we ran into a little bit of trouble. And that is right there. So we have negative 1/5 and then dB dt. So we had some questions like that where we had to plug it back in when we were trying to find the second derivative. Okay, so 100 minus b. So that is the second derivative in terms of b. Use that to explain why this graph cannot be the graph for that. Alright, so the bird's weight is going from from 20 to 100. If you look at this formula, if we plug in anything between 20 and 100, we're going to get a negative answer. So for b in between 20 and 100, the second derivative is negative, is less than 0. So the function should be, now remember that's the second derivative, and we're talking about the graph of b, which is the original. So if the second derivative is negative, then that should be concave down the whole way. Okay, but right here, that's concave up. Okay. And it's supposed to be concave down. It's concave up here. And you could write a little bit more, but can't be the graph because it's concave up. On part of the interval. Okay. Now, use separation of variables. So they're coming right out and telling you that. But usually, I don't know if they always say that, but what we do see is the particular solution to the differential equation. So that's what you want to look for. Okay. So if we go back to that and we do separation of variables, that's very similar to the example we just did. That's probably why I had that in the notes. 100 minus b dB, and then on the other side we got 1/5 dt. So if you compare that to that example, it's almost the same except these are switched around. Okay, so now that's separate. Now we're going to integrate. Now here's what I was talking about earlier. So initially we would just be like, oh, that's just the natural log. But I'm going to be careful there, because if we do U substitution on that, we're going to get a negative here. So just keep an eye out. And then over here, this is going to be 1/5 t plus c1. Alright. I don't know what color I used next. Blue. I got these two backwards. Anyway. So with that natural log, well, actually, I think what I'd rather do is knock that negative out of there. So switch this to negative 1/5 t, and maybe call that C2, because it was multiplied by a -1, so this value is different than that value, so that's what we're indicating there. Then we're going to raise both sides to those powers. So we're going to have 100 minus b equals, and we talked about this several times, so that's going to put a c in front. And there we go. Now we do have an initial condition right here. So when the time is 0, b is 20. So we're going to have 100 minus 20, and e, and when t is 0, that's going to be 0. So c equals 80. And so our final formula here is, well, technically, it's 100 minus b equals 80 here. And if we add b to that side and subtract that over and then flip the whole thing over, so there's your positive b, and the other side should be 100 minus 80 e to the negative 1/5 t. And that's going to be worth 4 or 5 points, you can see. And well, this whole thing, yeah. This is worth 4 or 5 points. The whole question is worth 9. Oops. I have that on there. Hope you, the last couple steps are pretty easy there. Alright, it's about that time. Have a good day. A little Magic 5 for you if you didn't get enough this week. Get a little magic. And have a good day.